Hey grade 9s, today we are going to work on improving our understanding of linear relations. At the end of this lesson, you should be able to graph a linear relation. You should be able to tell me whether it is linear or nonlinear. You should also be able to tell me whether, when drawing a graph of a linear relation, whether I should connect the dots or not connect the dots. Okay, so what is the definition of a linear relation? A linear relation is a relationship between an independent and dependent variable, okay? And it can be represented by a straight line graph. So what this also means is that it's a constant change. So constant means, say, increasing by 2. So as one variable increases, let's say by 2, a constant number, the other variable is also going to change by a constant amount. So when I'm talking about variables, I am talking about x and y. Okay, x is your independent variable and y is your dependent. So basically, as x would increase, y would increase, and depending on the amount of what the increase is. Okay, so things you need to remember is x goes on the bottom. This is your horizontal axis. Y goes up and down. It is your vertical axis. And this is always the case. In science, you learned about them being manipulated and responding variables. Okay, so which graphs represent a linear relation? We're basing it off of a straight line graph. So this one is linear, straight line. This one, even though they're not connected, there's dots on here, it does make a straight line. However, this one, you have an x and a y, but you'll notice there is a curve. This is not a linear relationship. Okay, so example 1. Is each graph a linear relation? So we can do this by looking at our table of values and also graphing it. We're kind of going to do 2 and 1. So we're going to look and say, okay, our x, is it increasing by a constant amount? Well, yep, it's increasing by 1 each time. So the x is increasing by a constant, but it's a constant change, but is y increasing by a constant change? Okay, well, plus 2, plus 2, plus 2. So y is increasing by 2 each time. So therefore, as x increases by 1, y increases by 2 every single time. So therefore, this is a linear relation. Okay. Excuse me. So if I wanted to graph this, or if I was given a visualization for a graph, I'm going to remember x comes first, it goes on the bottom, y is up and down. So x is 1, y is 4. So 1 over, up 4. 2, 6. So x is 2, y is 6. 3, 8. So x is 3, y is 8. 4, 10. So 4, 10, and 5, 12. You can actually see, if you kind of throw a ruler on there, it makes a nice linear relation. So if it was to ask you to write an equation, this is kind of from our last little section, I am going to remember that whatever it's increasing by here is going to help me find my coefficient. So what I multiply by, so y is equal to, looks like I'm increasing by 2, so 2 times x. To find what my plus or minus is, I go back to when x is 0. So if I'm increasing by 2, means this should be a 2, right? 2, 4, 6, 8. So it's plus 2. So there is my linear relation, and there is my equation. Okay, so looking at this one. Is this graph a linear relation? Okay, so let's look at x. plus 1, plus 1. So x is increasing by a constant change. Let's look at y. And 2 plus 3 plus 5 plus 7 plus 9. Is this a constant amount? Well, no, this is 3, this is 5, this is 7. So this isn't actually, it says not a linear relation. Okay. And show this to you on a graph. We're going to graph it. So x is 1, y is 2. So 1 up 2. X is 2, y is 5. So 2, 5. 3, 10. So x 3. This is y. Your dependent is 10. 4, 17. I'm looking like up here somewhere. And then even 5, 26. And we're looking like way up here. And so if you actually look and try to put a ruler on this, if you were trying to do this at home, this actually does not make a straight line. It kind of makes a curve. This is what we call, and you'll learn about this in grade 10. It's not a straight line. This actually makes an exponential graph. Okay? So we know because the dots do not form a straight line. Okay, example 3. You should be able to complete a table of values with any equation provided. So basically what that means is understanding how to fill in a table. Whoa, what's going on? Using an equation. So if y is equal to 2x plus 1, what's happening here is I'm going to go to, I'm going to put whatever value I have in for x into my x spot. So 2 times 1 plus 1, this is going to give me 3. 2x is now 2. I'm going to put it in for the x value. Plus 1 is equal to 5. 4 plus 1 is 5. 2 times 3, so this is just me filling in a table of values. Eventually, what you're going to get is you don't have to show this work if you're understanding how to put it in your calculator and figure it out, but just make sure you are write 1 or 2 out to make sure it works. And you will notice, okay, that you should be seeing an increase, so 3, 5, 7, 9, in your values by the same thing as your coefficient, because we know this coefficient tells us how much it increases by. Okay, so in this one, our x values are a little different, but we still can fill it in like normal. So y is equal to, so this is y is equal to 10 minus x. Well, here's your x's. So 10 minus x is 7 in this case. So our y is equal to 3. 10 minus 5 is 5. 10 minus 4 is 6. 10 minus 2 is 8. And 10 minus 0 is 10. So that is a completed table of values with the equation provided. Okay, so now getting into more common questions that you'll be getting in this situation. So example 4, you need to be able to graph a linear relation from a table of values. Usually it involves a word problem. So let's look at this one. A scuba diver goes underwater. The deeper he goes, the more water pressure he feels. Refer to the table to see the relationship between depth and water pressure. So you'll notice your diver's depth is meters here, your water pressure. So these are just your units. I'm going to use the variable d for depth and let's say p for pressure. Your x is always going to be your one on the bottom, and your y is going to be your one that is going up on top. So I'm going to actually just take a quick second and put these on my graph while I'm in the habit. Y is my pressure, okay, and x is my depth. So describe the relationship between the diver's depth and the water pressure. So how do we do that? We can do this in words. Okay, so when I mean in words, it's asking you, what is the relationship? So the diver's depth looks like it's going up by 5s each time. So as D increases by 5, P, let's see what P increases or decreases by. P increases by, looks like 50 each time. So P increases by 50. So there is the relationship in words. In a graph, okay, I am looking at, okay, I've got 0 to 20 on my X, so it looks like I've got enough spots here, so the 0 is always going to start right there. I'm going to go 5, 10, 15, 20. You do have to label with your numbers. And then your Y looks like you want to go up all the way to 200. So I should be able to go 50, 100. Yeah. So 50, 100, 150, 200, 300. All right. So now I'm going to graph this data. So D, your X is 0. Your water pressure is 0. I'll use a different color. So there's my 1 point. 550. So D on the bottom is 5. Pressure is 50. 10, 100. So 10 on the X, 100 on the Y. 15 and 150. And 20, 200. So there is my relationship on my graph. Is this linear? Okay. Does it make a straight line? Well, if you were to actually kind of put an invisible ruler on there, does it make a straight line? Yes, this is a linear relationship. Okay. Now, does it make sense to connect the points? This is something that's a little new to you. Sometimes you guys just automatically go, yes, I'm supposed to connect the points. It's not always the case. So it depends if you have what we call continuous data or discrete data. So here's your first definition. This would be a good thing to write down. Continuous data is when you can find values between the plotted points. So that means that we would then connect the dots because you could find a point anywhere in between the points that are actually plotted. So if we look at our word problem, does it make sense that you could have a diver's depth between 0 and 5? Well, yeah, that does make sense. Could you have a water pressure of like 10.5? Yeah, that also makes sense. So you can actually have data points in between the ones given here. So this example is what we call continuous data. And therefore, I can actually, probably not very well on this thing, but I can actually connect my points on my graph. Okay. Example 5. So we're going to graph another linear relation. In this one, the student council is planning on holding a dance. The profit is in dollars. It is 4 times the number of students who attend, minus, sorry, there's a typo, $200 for the cost of the music. So the first thing we're going to do, they don't give us an equation in this one. They're going to ask us to write an equation. So this is where I'm going to pull the information out given to me and decide what's happening. So the profit, so P, let's just take 1 second and erase that because you can't see it. All right, so P is equal to profit. So let's say P is profit. The number of students, do we know how many number of students? No, we don't. So I'm going to use, let's say, X for number of students. So 4 times the number of students, so 4X minus 200 for the cost of music. So there's my equation. I have identified my variables, and that part is important. Now we're going to graph the equation. Well, this looks a little tricky to graph at the moment, so the only way we can graph the equation is if we make a table of values. So we're going to do our x first, and our y, aka p, second. So I'm going to fill this in. So 4 times, let's go with 0 students. So 4 times 0, so x is 0, minus 200. Well, that puts us at a loss of $200. If I have 50 students, so 4 times 50 minus 200, I have made no money, but I've broke even. At 100 students, I have made $200, or the student council has made $200. At 150 students, 4 times 150, and you should be profiting 400. And at 200 students, 4 times 200, we're looking at $600. All right, so now we actually have a table of values, so now we can actually graph this. So x is going to be our number of students. Label your axes. And your y is your profit in dollars. All right, now we're looking at 0 on our x, 0 to 200. So let's look at, I'm just going to erase my work here so I have room. All right. So 0, I'm going up by 50s. So 50, 100, 150, 200, 250. Looks like I should actually have this extended down below a little bit, so I'm just going to do a little cheat. Negative 200. I can go up by 200s, 400, 600, 800. All right, that is important part of the graphing part. Unfortunately, it just is what it is. It's tedious, but so now 0, negative 200, 0, negative 200. There's my first point. 50, 0. That one's right actually on my x-axis. 100, 200. That's my next point. 150, 400. There's my next point. And 200, 600 is my last point. So there is my graph. Does it make sense to connect the dots? Okay. Same question as before. Does it make sense that I can have values in between these dots with what I'm working with? So the answer, hopefully, I have to erase this so you can actually read it, should be no, it doesn't. Okay, it does make sense that you could have a profit of $202, $200.10. That makes sense. Profit one does. But can you have 50.5 students? You could have 51 students, but you can't have 50.5 students. So because you cannot have an in-between, like a decimal value of the number of students or a half a student, you can't actually connect these points. So this is what we call discrete data. And so therefore, we just plot the points as is and we do not connect the dots. Okay? So last part is D. Can you basically how many students do you have to have in order to make a profit? So what does profit mean? Well, profit means make more than $0. So basically, if we figure out how many students you need to be exactly at 0, you need more than that. So if we take our equation that we have already created, which is P is equal to 4 times X minus 200. Basically, we're looking for a profit of 0. That way we know that we need more than however many students we have here. And now we actually use our algebra skills to solve for X. So I'm going to go plus 200 in order to solve for X. Now I have 4X is equal to 200. Ooh, there we go. 4 times X, I need to divide by 4 in order to solve X on its own. And X is equal to 50 students. So in the end, I need more than 50 students to make a profit. So that is all there is for 6.2 linear relations. I am hoping that you now have an understanding of what makes a graph linear and what makes it nonlinear. You should be able to tell me whether you should connect the dots or not connect the dots. So connecting the dots means it's continuous data. Not connecting the dots means discrete data. If you have any questions, reach out to your teachers and have a good rest of your day, guys. Bye.